Hey folks, I wanted to give you a little bit of supplemental information regarding the Math Excel for School related to Chapter 7, What's My Line? So you already know a little bit about line of best fit and regression and residual plots. Let's go ahead and take a look at a couple of extra things that I didn't go into a lot of detail and I want to make sure that you get. So we're going to talk today about slope and its interpretation in the context of an equation of line of best fit. And we're going to talk about standard deviations. Okay, two things. So let's start with number one. We're going to talk about slope. So in this particular equation that you see here, what I'm trying to do is I'm trying to relate two variables. The explanatory variable is months. That's our x variable. And our response variable is cost. That's our y variable. The situation is this is the equation for what it would cost you for membership at a gym. You might have to pay a $50 fee just to join, and then you might have to pay something like $36 per month. And if that's the case, well, the number of months, depending on the number of months, that will dictate how much the whole thing costs. Now, by the way, you'll notice that I have a funky little thing over cost. That's my hat. You might recall that the equation for line of best fit is y hat equals something like a plus, we'll do a plus bx in this case. And in this case, b is the slope and a is the y-intercept, and the y hat is the predicted value of y based on the line of best fit or the regression equation that we calculate. So anyways, that's the overview of this situation. Now, the main thing I want to talk about, that's just a refresher. The main thing I want to talk about is how do we interpret the slope? And the slope is this guy. The slope is the number that's in front of our explanatory variable or our x variable. So what are the units for that slope? There are some units there, and we can figure it out pretty easily. See, we know that whatever these two things add up to, they have to add up to cost. And cost, I'm assuming, is in units of, can you beat me to it? Pause the video for a second. See if you can figure out what the units are for cost. Okay, hopefully we agree. The units for cost are dollars, and this is probably $50 up front. And then then the number of months is time, and then for the slope, let's figure out what the units are associated with the slope, this 36. So if this is dollars right here, if the 50 is dollars, then when we multiply 36 times months, we better darn well also get dollars. Okay, and by the way, we also know that cost is in dollars. Okay, these two dollar amounts have to add up to a dollar amount. Okay, so if that's the case, then if I go and I take the 36 and I want to turn that into dollars, I must have units of something like, I think it's going to be cost over months. I believe that is going to be the units of my slope, and then we can then multiply that times months, and then the months cancels out, and we simply get 36 times whatever the cost is. So what does the slope mean in this case? It means that for every one, I'm going to write it another way. What it means is $36 in cost for every 1 month of membership. That's the interpretation of the slope here. Let me spell it out for you. I expect you guys to add this to your notes, and I expect you to be able to interpret the slope appropriately in the problems on Math Excel. Now, let me give you one more little another bit of information. I took a little bit of time to pre-write some of this stuff out. The formula that we're concerned about here is this. It's z of sub y equals r times z sub x. Z sub y equals r times z sub x. Z sub y is the number of standard deviations from the mean of all the y values. Z sub x is the same thing for x values. In other words, Z sub x is the number of standard deviations from the mean of all the x values. So if we took all of the y values and we found the mean, this Z would be how many standard deviations we are away from that mean for a particular y value. And this would be the number of standard deviations from the mean for a particular x value. It turns out that we can relate this number of standard deviations for our response variable to the number of standard deviations for our explanatory variable. We can relate them to each other by R, the correlation coefficient. So if you are given a correlation coefficient and you're told that the y variable has increased by so many standard deviations, then we can figure out how many standard deviations the x variable would increase by. So again, this is only true for where a linear model is appropriate, obviously. Let's try a sample situation. So let's say that we are told in a particular situation our R is equal to 0. Let's make it a reasonable R because so that we believe that a linear model might be appropriate. So we'll say something like 87. R equals 0.87. That's a pretty high R value, not skyrocketing high, but pretty high. And let's say that we know that what we want to know is in a given situation, if the standard deviation of values rose, let's say, from where it currently is, we'd like to know how much would the standard deviation rise for the x values. That's what we're looking for. We know what the standard deviation. I'm sorry. Let's see here. Yeah. Okay. So we're going to know y. So let's say that y. Then we raise the y values by 2 standard deviations. Or let's make it more interesting. Let's make it 1.5 standard deviations. Okay. And what we'd like to know is well, how many standard deviations would the x variable change by? This is what we're looking for. Okay, and the math is rather straightforward. It's just some simple algebra. So we just do something like, well, let's see here. We're going to do 1.5 equals 0.87 times z sub x. Divide both sides by 0.87, and we get z sub x equals 1.5 divided by 0.87. And we will then be able to see how many standard deviations our x value rises by. So let me do the math real quick. Okay, so somewhere or another I got a calculator, there we go, and I divided 1.5 by 0.87, there it is, you can see the math up there, and the result was 1.72, so the answer to our problem is going to be z sub x is equal to, I think it was 1.72, let me take another look. Yeah, well, and we could round to 1 decimal place because z sub y was given to us with 1 decimal place, so we'll say 1.7, and there is the answer to our question. I think you're going to need to know that and the thing about slope if you want to be able to complete the Math Excel for School for Chapter 7. I wish you good luck, and you know how to get in touch with me if you have questions.